Alright guys, so this is the last video. We're going to talk about decomposing functions here. So with decomposing functions, we're saying we have one function that is constructed of an outside function and an inside function. In other words, we got our h of x here by putting g of x inside f, right? And what we're looking to do with decomposition is determine f and g of x so that when we compose them, they give us our h. Right? So one thing I think is a good way to sort of think about this is if we can figure out what g of x would be, right, then we can take g of x out of f, and whatever's left over would be our f of x. So right here, the thing that we want to remember when we're taking out g of x is that we can let g of x be any series of operations that are happening directly to x as long as we take those operations in order. So if we look at our h of x right here, right, which is of course our f of g of x, really, right, we know that g of x is operating on x first. So that means that g of x are going to be a series of things that happen to x before f happens to x. So let's count out the things that are happening to x here. First, we're seeing a multiplication of 3. Then we're seeing a subtraction of 5. And then that number is dividing 1. So right here, if we are looking to identify a g of x, we could say g of x is just going to be that first thing that's happening to x, right? And in that case right here, we would have g of x as 3x. And then when we take out that 3x, what we'll be left with is our f. So right here, taking out that 3x, we've got f as subtracting 5 from something and dividing 1 by that number. So when we plug in x, we have f of x as 1 over x minus 5. So right here we would have f of x as 1 over x minus 5. And we got that by sort of pulling out a g of x. Now this isn't our only option for our g of x here. We sort of take all this out and set this up again. We could say, got g of x in there again, and here's our 3x. We could say that g of x isn't just the first thing that's happening to x, it's also the second thing that's happening to x. So we could say that it's the first two operations that are happening to x, right? So taking out those first two operations in order, we have g of x as 3x minus 5. And then when we take out that g of x, again, what we'll be left with is our f of x. So right here, that leaves us with f as the act of dividing 1 by some input, right? So f of x would be 1 divided by that input, and we could then say that f of x would be 1 over x. Now the test here is always, can we compose these choices of f of x and g of x to get h of x back, right? So g of x is going to be the inside function, f is going to be the outside function, and right here, if we try our first one, we would have f of something as basically taking an input, subtracting 5 from it, and dividing 1 by that number. And when we plug in g of x, we'll then have 1 over the input of g of x minus 5. So that would be 1 over our 3x minus 5, which is our original function. So that one works. And then right here, if we look at our second one, we would have f as basically being 1 over some input, and then right here when we plug in our g of x, we can say that input is going to be our g of x, which is 3x minus 5, so 3x minus 5, and that of course also gives us back our h of x, right? So both of these guys work. Now one thing that we're not saying here is that neither f of x nor g of x is going to be the identity function, right? So the identity function is the function that when we plug in an input, we get that same number as an output, and basically it's the function that has no operations, right? It's basically just giving back that input as the output. And we're saying neither f nor g could be the identity function. So there has to be some operation that we're attributing to both of those guys. And if we count out our operations, we've got 1, 2, 3 operations here. So really we've accounted for all of our possibilities, right? Because either the first operation is g of x, and then the second 2 operations are f of x, or the first 2 operations are g of x, and the last operation is f of x. If we let f of x be all 3 operations, then g of x would have to be the identity. And if we let g of x be all 3 operations, then of course f of x would have to be the identity. So right here, I think you guys probably have a reasonable grasp of this. We've got 2 of these to look at. What I would say is definitely come up with one possibility for g and f of x that would come together and give us an h of x for both of these. I would say that for the first of the examples you're going to try, you could come up with all the possibilities. Right here, the h of x is going to be a little bit tougher. There's one definite possibility that I want you guys to be able to get there. So why don't we pause the video here, and we'll let you guys try these last 2 on your own. All right, guys, so looking at these, for the first example we had you guys try, there are 3 operations happening to x. It's being raised to the 3rd power first, and it's having 1 added to it, and then finally the square root is being applied to that number. So right here, our choices are basically, it could be that just the first thing happening to x is our g of x, and that would mean that the second 2 operations that are being applied to the input would be our f of x. Or it could be that the first 2 things are our g of x. The first 2 operations being applied to x are our g of x. And right here, that would leave f of x as the last operation that's happening to the input, that square root. With this last one right here, there's one easy one. I mean, right here, we can see x plus 1 in 2 parentheses here. And so what we can do is take out that as our input, and then right here, what we'd be left with, if we had, let's say, have g of x as our x plus 1 squared minus 3 times x plus 1. And I'm going to squeak this 4 in right here. Now right here, of course, taking out that x plus 1 as the g of x takes the input out of 2 places. Now we've got, use the smaller eraser there, we've got f of x as basically being some input squared minus 3 times that input. And then when we plug in x here, we've got f of x as x squared minus 3 times x plus 4. And of course, we can check all of these to make sure that they give us back our h function, but they should all work. So this is the last video. We're going to do some problems on a worksheet, our next class, and we will answer any questions you guys have on this as well. All right, guys, so see you next class, and we'll talk about all this again then.